Today we're going to finish section 12.1 on one-way ANOVA. So we can use the date of May 11th for our notes. And before we go any further, if you'll take a minute and enter this data into your iPad, we have 3 different categories: mid-size cars, sport utility vehicles, and pickup trucks. So if you need to, pause it at this time. Now that your data's in, the question that we're asking is, do SUVs and trucks have lower gas mileage than mid-size cars? Once the data's in, we're going to look at some basic information. So right now the response variable is gas mileage in miles per gallon. We have 31 mid-size cars, 31 SUVs, and 14 pickup trucks. So we have 76 observations total. The first thing we want to look at is the mean for each category. So you can see that the mid-size mean is a little bit higher than the SUVs and the pickups. Now, is it really statistically significant, or is it due to chance? We also want to look at a graphical display to make sure that the distributions are normal and that all the assumptions for running a one-way ANOVA are met. And they don't look too bad. The mid-size is pretty normal. SUVs, couple different peaks, but otherwise not too bad, no outliers. Same with pickups. So are these differences statistically significant? So before we run the test, we want to state our hypotheses. The null hypothesis says that all the means are the same. So mu1 equals mu2 equals mu3. I'm maintaining the order that they gave us the information in. So mu1 would be mid-size, mu2 is SUV, and mu3 is pickups. The alternative says at least one mean is different, but beyond that, we don't know if more than one mean is different or they're all different. We just know at least one is. So on your iPad, I'm going to have you go ahead and run the ANOVA so that we can fill in our table. So under source, we have groups, then error, then total. We have 3 different groups that we're examining. So degrees of freedom is I minus 1, so it will be 2. Error is N minus I, so we had 76 observations. We had 3 different groups, so degrees of freedom is 73. And that total then is 75. You can double check this on your iPad. Now from the iPad, we're going to pull the sum of the squares for the group. And then the sum of the squares for the error. Now the total isn't listed, but I'm going to go ahead and total this column. Again, from the iPad, the mean square for the groups and the mean square error. From these 2 values, we will go ahead and set up the ratio and run the F statistic. And that is significantly high. And then using the iPad, if you just hit the value where they display the p-value, we can see that it's essentially 0. It's actually so tiny that they use scientific notation. So what does that mean for us? This is a Minitab output for the one-way ANOVA, and they did get the same results that we got on our iPad. So at a 5% level, we do have significant evidence that the means are different. What's cool about the Minitab output is they actually run the 95% confidence interval for your mean. So in this first row, this is the information for the mid-size car. There's the confidence interval. But then for the SUV and the pickup, you can see that they're actually similar, but these 2 confidence intervals are significantly different than the mid-size car. So the conclusion we're drawing right now is there is significant evidence that the 3 types of vehicle do not have the same gas mileage. And then based on the means that we obtained originally and the confidence interval, and then the result of our F statistic, the SUVs and the pickups have poorer fuel economy than the midsize car. Let's go ahead and try another example. You can pause it at this point. We have information for 3 different magazines, the Scientific American, Fortune magazine, and the New Yorker. So if you'll take a minute, you can read the scenario and then get your information put into your iPad. So they're looking at the fog index for 3 different magazines, basically identifying which magazines might be more difficult to read. So each magazine will be tailored to a different type of person with different levels of education. Once you put your 3 sets of data in, we're interested in the mean. So for Scientific American and Fortune, and they'll seem fairly close. And then the New Yorker. So that one does seem different. Now you're going to go ahead and run the one-way ANOVA on your iPad so we can complete our table. So again, we were using 3 different magazines. So degrees of freedom is 2. We took a sample of 6 ads from each of the 3 magazines. So there were 18 observations. So 18 minus 3 is 15. And then total is 17. So from the iPad, the sum of the squares for the group, sum of the squares for the error, and our total. Mean square, remember, can be calculated by taking the sum of the squares and dividing it by the degrees of freedom. Your iPad does this for you. So the mean square for the groups and the mean square error. With these 2 values, we'll calculate our F statistic. Kind of high. And then ultimately, if you tap the cell where the p-value is, we can see that it does seem significant at alpha equaling 0.05. So at this point, we would conclude that there is significant evidence that the reading level are different between these 3 magazines. We also want to examine the confidence interval. Cool thing, on your iPad, when you run the ANOVA test, they actually give you the confidence intervals. So you're looking for the cells that say C, lower list, and C, upper list. You have to remember the order that you put the variables in is the order they're listing the lower limit and the upper limit. So we put in the Scientific American magazine first, at least I did. So when I tap on the lower list, the first value is the lower end of the confidence interval, 9.34, and I did round it. And then if you tap on the cell for the C upper list, the first value there is for Scientific American as well. My second variable was Fortune magazine. So it will be the second value in the C list for lower and the C list for upper. These confidence intervals are fairly close. There's a little bit of overlap. And the third variable was representing the New Yorker magazine. And when I look at that confidence interval, I can see that it's definitely different. In fact, the New Yorker's confidence interval has no overlap with Scientific American or Fortune magazine. So my conclusion based on the confidence interval and then running the F statistic is that it appears, and I don't want to say this in my conclusion, that the New Yorker does differ, but it is possible that the other 2 differ from each other. The follow-up to that would be running a contrast, and we'll examine that in 12.2. So we're going to complete problem 1223, and I will send you the data. And then we're going to do 1224A only, and it's the same data. If you have any questions, please make sure you contact me. And otherwise, have a great day.